Hey guys, today's lesson is going to look similar at first to yesterday's lesson. So this one is on factoring trinomials, but this time they're in the form of ax squared plus bx plus c. So they've got that a. So we're going to do it a little bit different. That means instead of just being x squared or c squared or m squared or whatever, it's going to be like 2x squared or negative 5x squared or whatever. So there's a coefficient other than 1 in the x squared term. So we're going to do this a little bit different and a little bit the same. Now, there are examples here and information here for how to factor. But we're going to go back to that box. Remember when we were multiplying binomials and we used that box? We're going to go back to that today. So I'm going to skip through the examples and we're going to dive right in. Now, be careful because sometimes we can't factor trinomials. So look at your directions. Factor each trinomial if possible. If you can't, then we would write the word prime. We'd say it's prime. Okay, so just be cautious because sometimes we're not going to be able to factor these. So notice here, my trinomial is 2x squared minus 3x minus 2. I cannot do the exact same thing I did last time in the last lesson. In the last lesson, I just looked at the constant term and listed out his factors. And the reason I was able to do that is because the x squared term was just x squared. There was only a coefficient of 1. This is different. So what you're going to do now is you're going to take the coefficient of the x squared term and your constant term, don't worry about their signs right now, and multiply them together. So 2 times 2. So I'm going to write 2 times 2, which is 4. And then let me zoom in. And then you're going to list out the factors, the factors of 4, not 2. So 4, the factors of 4, 1 times 4 and 2 times 2. From those factors, you want a pair whose sum is going to be negative 3. So that's going to have to be 1 and negative 4, right? So now make your box. I'm not going to do my parentheses yet. Make your box, okay? So I know that in this box, so we know what's going in these 4 boxes. We're trying to figure out this time what goes here, 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 and here, the outside of the boxes, right? Well, we know that this box has to be 2x squared. So I'm going to write 2x squared right there. And we know that this box, that's where our constant term is, which is right here, negative 2. So negative 2. What we did not know was what goes here and here. But we found that out. It's going to be a 1x and a 4x. Except for we want to have negative 3, so it should be 1x and negative 4x. And it doesn't matter if I put the 1x here and the negative 4x there, or if these two are switched places. That won't make a difference, okay? Now, what I want you to do is I want you to look here. Between x and negative 2, what is the greatest common factor there? 1. Right? And then look this way. What is the greatest common factor between 2x squared and negative 4x? 2x can be pulled out. So I'm going to write 2x. Then I'm going to go this way. What's the greatest common factor between 2x squared and x? X. And what's the greatest common factor between negative 4x and negative 2? Okay, so I can pull a 2 out. I'm also going to pull out a negative. So I'm going to write negative 2. Okay, and so when I factor this out, okay, I end up across the top I have 2x plus 1. And across the side I have that x minus 2. So it factors into 2x plus 1 times x minus 2. That's it. That's it. Let's try number 4. I'm going to do another one, okay? All right, so what did I tell you had to do first? So you want to look at the x squared term and the constant term. They're both 6's. Don't worry about your signs right now. So we're going to do 6 times 6 and that's going to give me 36. Okay, and then I'm going to list out the factors of 36. So 1 times 36, 2 times, is that 18? Okay, 3 times 12, 4 times 9, and then 6 times 6. Okay, I want a pair that's going to give me positive 5. And it looks like the 4 and the 9. All right, now I'm going to make my box. Okay, we already know what goes in the top left. That's that x squared term, which in this case is 6x squared. And we already know what goes in the bottom right, which is our constant term. That's that negative 6. The other two boxes are going to have the 4 and the 9 in them, right? But we want a positive 5, So that's going to be 9x minus 4x. Okay, so now we've filled out the box. Now we can just do the GCF. So let's go this way first. The greatest common factor between 9x and 6 would be 3. So I'm going to take out a 3. If I go this way, 6x squared and negative 4x, I can take out 2x. If I go this way, 6x squared and 9x, I could take 3x out, or factor 3x out. And then this way, negative 4x and negative 6, I can factor out negative 2. Now let's talk about when you take out a negative. So it doesn't ever matter if this box right here is negative. Okay? Don't even worry about that. If this box is negative, then right here comes a negative. If this box is negative, then right here comes a negative. Okay? So be careful with that. All right, so this is going to be 2x plus 3 times 3x minus 2. Let's do another one. Number 7. So again, we're going to, remember when we multiply, we're going to do the 2 and the 3 first. So 2 times 3 is 6. So we're going to want the factors of 6. I'm going to go ahead and make my box real quick. So we know the upper left box has to have the 2a squared. The bottom right box has to have the 3. Okay, and we're trying to look for a pair of factors that gives us a positive 5. So we need to be careful because we can get a positive 5 by doing negative 1 plus 6 or positive 2 plus positive 3. So either one of these can give us a positive 5, but we want to multiply so that we have a, well, forget the 3, but we want to multiply so that we have a positive over here. So if I'm using this one, the 1 and the 6, that would be negative 1 times 6, right? Which would be negative. So it looks like I need to use that 2 and the 3. So why don't I actually write it in pink? So I'm going to do the 2x, oh, not x, sorry, my variable's a, 2a and the 3a. So when I factor this way, the 2a and 3, you can only pull out a 1. When I go this way, 2a squared and 3a, you can factor out an a. When you go this way, you can take out 2a. And when you go this way, you can take out 3. So I end up with a plus 1 times 2a plus 3. Okay, let's do number 10. Okay, number 10 is 8x squared minus 4x minus 24. Before you get too far into this one, there is a common factor between all three of those terms. You can factor a 4 out, and you need to do that first. So if I factor a 4 out, that leaves me with 2x squared minus x minus 6. So be careful. Do that first, and then you're going to factor this further, if possible. So I'm going to do 2 times 6, and I get 12. and then list out the factors of 12. Okay, and then I'm going to come over and do my box. So I'm going to put a 2x squared here, a -6 there. And then I'm looking for a pair of factors that would give me -1. Okay, so it had to be the 3 and the 4. And be careful, they need to multiply and give me negative. So 3 plus -4 would be -1. And then a negative times a positive is a negative. So that'll work. So I'm going to write 3x and -4x. So when I factor, when I come this way, I'm going to get a 3. When I come here, I'm going to get a 2x. This way you get an x. This way you get a -2. Now, see that 4 right there? Don't forget it. You need to bring it down. So bring down the 4. And then times 2x plus 3 times x minus 2. If you don't have that 4 right there, then it's wrong, okay? So be careful, because sometimes they're going to give you trinomials, which you're hopefully notice in number 13 they're doing it again, where there is a common factor. So before you do the two factors, you need to take out the GCF. So I can, for number 13, factor out a 3, leaving me with y squared minus 2y minus 8. Now, we just talked in the last lesson about the factoring trinomials like this. We don't necessarily have to do that box, but we could. So I'm going to think, if you think about this one, the coefficient here is 1, the coefficient here is 8. 1 times 8 is 8. So the factors of 8 are 1 times 8 and 2 times 4. You want a pair that would make -2. So that's going to have to be this pair. So if I used the box method, let's do that again. That would leave me with y squared there and -8 there. And I'd have to have 2y and -4y. Leave me with a 2 is the greatest common factor there. Here my greatest common factor is a y, another y, and a -4. So I'm going to bring down my 3 that I factored out times y plus 2 times y minus 4. Now, you didn't have to make this box. You might have been able to just jump right into the parentheses here like we did in the previous lesson. I was just showing you that you can still use that here. All right, let's do one more together. So 6x squared minus 7x plus 18. So I can't factor anything out here. So I'm going to first do 6 times 18, and I'm going to get my calculator here. 6 times 18 is 108. This is where it gets a little messy. Then I have to list out the factors of 108, which I don't know them all. I think 3 goes into 108. It does. And 4 will go into 108. Not 5. Will 6 go into 108? Yes. I'm going to try 108 divided by 7. No. 108, divided by 9. I know it's not divisible by 10 or 11. And then 12, I've already got 12 written down. Okay. So then I'm looking for the pair that would make a -7. Okay, well, 12 and 9, 12 minus 9, that's not going to work. And 6 and 18 doesn't work either, does it? 18 minus 6, no. There's no way I'm going to get a -7, is there? There's no way. So this can't be factored. This is prime. So there's an example of a prime, okay? All right, now it's going to be your turn. So you're going to do the middle column again. And you can skip the third one. So do the middle column. Pause the video and do that now. All right, guys, so we're going to check over these problems now, and as you're checking, make any necessary corrections. So you should be able to check 2, 5, and 8. So let's pause the video and get that now. Okay, and then there's 11, 14, and 17. Before we move on, I just want to point out number 17. I hope you didn't say prime because you can factor the 2 out. But once you factor that 2 out, a squared minus 7a plus 9, that portion is prime and can't be factored any further. But the entire problem, the original problem, is not prime. Okay, so we're going to go to the next page. And on this next page, it's the same thing, but this time we're going to be solving by factoring, which is similar to what you've done earlier. So if you're looking at these problems, you can see that we're going to set the equation equal to 0, just like we did in the last lesson. So let's look at number 1. The equation is already equal to 0 or set equal to 0, so I'm going to factor that. So I'm going to follow those same steps. Remember, you're going to do 8 times 3 first to give you 24, and then you want to list out the factors of 24. Okay, and now we're looking for a pair of factors that would give us a positive 2, so that's going to be right here. Okay, now I'm going to do my box method here. We know that 8x squared would be in the upper left and the negative 3 in the bottom right. And the 4 and the 6, we're trying to get a 2, so a positive 2. So it's going to be a positive 6x and a negative 4x. And now we're going to factor. So here we can factor out a 3. We can factor out 4x this way, 2x that way, and only a negative 1 there. So this is going to become 4x plus 3 times 2x minus 1, and that's all equal to 0. So either 4x plus 3 is 0 or 2x minus 1 is 0. So 4x is equal to negative 3, so x would be negative 3/4. 2x is 1, so x would be 1/2. So my solution set is negative 3/4, 1/2. That's it. So this is just extending what we've already done. All right, let's look at number 4. So for number 4, I'm going to move everything to the left side so that it'll be set equal to 0. In doing so, I'm actually subtracting the x and the 3 on both sides. All right, now I'm going to factor it. So 4 times 3 gives me 12. And the factors of 12, I'm listing them out now. And we want a pair that would make a negative 1. So we can use that pair right there. Let's get our box ready. So I'm going to write 4x squared there and a negative 3 there. All right, so I want a negative 1, so that's going to be a positive 3x and a negative 4x. So this way we can factor out a 3, 4x this way, x, and negative 1. So this becomes 4x plus 3 times x minus 1 equals 0. So 4x plus 3 is 0, or x minus 1 is 0. And then I'm just going to solve them both. So that, yeah, the x is negative 3/4 or 1. Let me do that better. Okay, I think we'll just do one more, and then I'll let you do some on your own. All right, let's look at number 7. So that's going to be 2k squared plus 11k minus 40. Okay, and then I'm going to do 2 times 40, which is 80, and then list out the factors of 80. 5 times what? Let's see. 80 divided by 5 is 16. I don't think it's divisible by 6, is it? No. And that would be 8 times 10. All right, we want the pair that would make 11. 16 minus 5 is 11. So that one would work. That's 2k squared. That's a negative 40. I need a 16k minus 5k to give me 11. All right, the 16 and the 40, we can take 4 out. Oh, scratch that. We can take 8 out, can't we? There we go. And the 2k and the negative 5k. So that's just going to be k. We can take 2k out this way. Negative 5. So we end up with k plus 8 times 2k minus 5 equals 0. So k plus 8 equals 0, or 2k minus 5 equals 0. So that would be negative 8 or 5/2. You can leave that as an improper fraction. And that's true for all of these. Okay, so I'm going to have you just do 2, 5, and 8. You can skip over the rest. So I want you to write skip though for me. So we can skip that. Okay. So I only want you to do 2, 5, and 8. You are certainly welcome to do more, but just pause the video and do 2, 5, and 8 right now. Okay guys, so I want you to go ahead and check over your answers. So you should be able to check over problems 2 and 5. Go ahead and pause the video and do that now. And here's number 8. Okay, it's really important that you have shown your work for each problem. So if you didn't, you need to go back and do it. If you have questions about any of the problems that we've done in this lesson, please see me. I'm happy to help. Once you've completed this, go ahead, work on your independent practice.